This video is about parametric equations. In order to start off our notes, we're going to create some workspace on one page of our notebook. So what we're going to do is get a colorful piece of paper and fold it into a trifold, similar to that made for the course information sheet on page 2 of the notebook. Dividing our paper into 3 equal parts, it will give us 5 panels in which to work information. One panel we will use for the title page, the 3 inside panels we will use for information, as well as the back panel. So on the first panel, which is the title page, we're going to use some markers in order to write down that this is about parametric equations, and we're also going to talk about what they are and that they come into a set of x of t and y of t. So it will graph the points x of t, comma, y of t, where x of t is a function of t and y of t is also a function of t. And we can call that f of t and g of t, meaning that our points will actually be the value we get for f of t and then the value we get for g of t. And that will create our points. And we're going to have special ways of finding parabolas, circles and ellipses, and hyperbolas, and we'll talk about those in just a second. First, I want to make sure that we talk about our calculator. So I'm going to come into my calculator into the mode key. Notice that I have moved down until I have highlighted the parametric key. So this way our calculator is now in parametric mode. When I hit y is equal to, we can see that it's looking for a set. So this is similar to what we had before. This is our set for x of t and y of t, and we can graph more than one. So with that, let's keep going on with our notes. On the inside, when we open up our trifold, we have 3 distinct sections. So with our marker, we can write down parabola on the first inside panel, ellipse in the middle inside panel, and hyperbola in the last of the inside panels. And now we're ready to continue our notes. So on the inside for the first panel, when we're talking about parabolas, we're going to be given an equation. As we can see, we have an equation here. From what we know about parabolas, we know that it has 2 y values for 1 x value. So this will either open to the right or to the left. Because we have a negative right here, we know that it's going to open to the left. So we know our parabola will look like that. So in order to put this into parametric form, what we're going to do is get whatever is squared and call that t. So notice that the y plus 2 is squared, so t is equal to y plus 2. And what's on the other side is what we're going to make t squared equal to. So t squared is negative 4x minus 1. So the next thing we're going to do is solve for x and y. So for the first equation, this one right here, if I'm solving for y, so t is equal to y plus 2, so I can see that y is equal to t minus 2. So one equation is going to be y is equal to t minus 2. Let's do the same for solving for x. So now we have t squared is equal to a negative 4x plus 4. Solving for x, I'm going to subtract 4, so I get t squared minus 4 is equal to negative 4x. And then I'm going to divide everybody by a negative 4. And we can see that our x is equal to negative 1/4 t squared plus 1. So these are our equations, our parametric equations that we can stick into our calculator and see this being graphed. So let's do that now. So for our x equation, we had that x is equal to a negative 1/4 t squared plus 1. And for y, we had that was equal to t minus 2. So now we can see our window. I want to show you that it's going to go from 0 to 2 pi, and this is the step it's going to take, and it's going to have our standard window of -10 to 10 and -10 to 10 for the x's and for the y's. So let's hit graph, and notice that we only have 1/2 of my parabola, so we're going to go to my window, and so that we can see all of it, I'm going to pick a negative whatever big number I want. So I'm going to go ahead and pick 25, and then I'm going to go to a +25, and I'll go ahead and leave the increments as they are. This will slow down our calculator when I hit graph, because what it's trying to do is going from -25 to +25 and hitting every one of those decimals that I asked it to do. So here we can see that our parabola does indeed open to the left. You can try doing the same thing and graphing this parabola. And that concludes this video.